Hello everyone, welcome to one of the final sections, and here I'll be talking about AWS Lambda. Just an underlining that I'll be talking AWS Lambda in the context of data processing only, because Lambda can be used in different scenarios and Lambda can be used for different use cases also. But we'll talk only about the times when you can use Lambda as a data processing tool. In most of the cases, you'll not be using Lambda for data processing as such because there are a lot of constraints which limit Lambda for data processing. You'll get to know about it in this section itself. So first of all, before even talking about Lambda, I wanted to introduce you to the term serverless compute. You already know what a serverless compute is. We have seen serverless MSK, we have seen serverless EMR also, and Lambda also falls in the same category, but the difference here is that Lambda gives you only serverless compute capabilities, wherein EMR serverless gives you serverless distributed processing, and MSK serverless gives you serverless distributed message broker. But in case of Lambda, it is only compute. Now, what is compute? Compute is something which gives us resources to execute a program. Now, when I say resources, it is typically RAM, CPU, and certain amount of storage if possible. So that's what compute is. So Lambda is a serverless compute offering from AWS, and it is serverless for users. It is not serverless for AWS. What I mean by that, behind the scenes, AWS will have servers, let's say in different AZs. Here I'm showing you two set of servers. The first set of servers are in AZ1 and the second set of servers are in AZ2. But these servers would be invisible to the end users. Will not be able to see these servers. And what we do is that we execute code without provisioning any server, because as it is serverless, we do not mention how many servers do we need. We just upload the code and execute it using the servers which are already there and which are not visible to the end users. And it does not mean that AWS does not have any servers. AWS has servers running behind the scenes. For Lambda, they use something called micro VM, and the code name for that micro VM is Firecracker. So whenever we run any code, whenever we try to execute any code using Lambda, we do not have to provide the number of servers. We just mention the amount of RAM that we need, and Lambda automatically provisions that much amount of memory and its corresponding number of CPU for the code to get executed. And one of the biggest limitation of Lambda is that the maximum execution time as of this recording is 15 minutes. If your code execution time goes beyond 15 minutes, then Lambda will terminate automatically. And this is one of the biggest reasons that Lambda is not used for distributed processing. Because you might have seen so far that all the Spark jobs that we have executed, it can be batch job or it can be streaming job. In all the cases, the execution time is way more than 15 minutes, or it can be within 15 minutes also. In production scenarios, it would be more than 15 minutes, and in those cases, we cannot use Lambda for the processing of the data because it cannot give us an execution environment which is more than 15 minutes. This is the first reason, and the second reason is that we cannot run the distributed processing framework on Lambda, meaning we cannot run libraries like PySpark, Scala, Hadoop, HDFS, etc. on Lambda, because Lambda does not give you a serverless distributed processing environment. That is not the case. It will give us compute to execute a code. We just upload the code and we can execute the same code as many number of times as possible, either parallelly or sequentially, but it does not give us the capability to run distributed frameworks like Spark, Hadoop, Presto, Hive, etc. So that's why we cannot use Lambda for distributed processing. But if you execute code, let's say if you are execute a simple Python code without any bells and whistles of the distributed processing, and if your code needs more CPU and more memory, Lambda would automatically scale up. And when the requirement is not there, it will automatically scale down. And the billing is on the execution time, how long your code is getting executed. It also gives you high availability out of the box, meaning that I had already shown you in the diagram here that servers would be there in multiple AZs. I'm showing you only AZ1 and AZ2, but it can be there in multiple AZs. Let's say a single region has a minimum of 3 AZ, then the micro VMs would be there in all those availability zones. And whenever we execute a code using Lambda, and let's say there's a requirement of scaling, and the code is running multiple times concurrently, the same code. So in that case, the individual executions would be scheduled in different AZs. It will not be on a single AZ, it would be on multiple AZs. So that's why it gives you high availability out of the box. And the most important use case of AWS Lambda is that it is used in event driven processing. What I mean by that is it will get triggered only when there's a certain event that has happened. We cannot use Lambda to run a code continuously. So let's say if there's a requirement that you have to keep your code running 24/7 for some API or something of that sort, you cannot use Lambda in that case, because it ties back to point number 2, that the maximum execution time is 15 minutes. So that's why it is suitable only for event driven processing, wherein the processing time is not more than 15 minutes. So let's say there's an event that has happened and you want to execute a code automatically. You can hook up Lambda with that, and whenever that event happens, the code that we have provided to Lambda will get executed automatically. You'll get to know about it in the next slides itself. And it has integration only with AWS services. Lambda is not an open source framework as such. It is not an open source serverless compute. We can use Lambda only with AWS services, other AWS services, and it has a very limited usage in data engineering. As I've already told you that there are various reasons. One of the major reason is that the maximum execution time is only 15 minutes as of this recording. The second major reason is that Lambda does not support any of the distributed processing framework. Either it is Spark or Hive or Scala or Presto. You name any distributed processing framework, none of them would be supported in Lambda. So that's why the usage of Lambda in the data engineering world is very limited, where you want to do some event driven processing and you are sure that your data processing would be completed within 15 minutes. Now, some of the use cases that I can think of is S3 file processing. So whenever you upload a file, let's say on S3, you want that the file should be processed and a processed file is saved maybe in S3 again. And you know that the size of the file is less and the execution or the processing will not take more than 15 minutes. In that case, you can use Lambda. So whenever you upload a file in S3, a particular code that you have configured with Lambda will get executed automatically whenever there is an upload. Now it is not only upload, it can be delete also, it can be copy files also, etc. This is one of the data engineering use case. Another use case that you can process data in Kinesis. So let's say your data is coming continuously in Kinesis, and let's say after every 10 seconds or 15 seconds or 30 seconds or 10 minutes, does not matter, after a certain duration you want to process the data using Python or Java or simple code without any distributed processing framework. You can do that using Lambda. You can do it if you know that the processing is very lightweight, you are not doing any aggregation, you are not doing any transformation as such. In those cases, Lambda can be used. But if you are doing aggregation, if you plan to do various transformations, then you cannot use Lambda. So there's another use case wherein you can process data which is available in SQS. SQS is AWS Simple Queue Service, which is used for application decoupling. It is not used for data processing as much, but it can be used to communicate data across various applications or across various APIs. Now, in those cases, you can use Lambda and process the data which is available in SQS. As I said, SQS is used for application decoupling. It is not used like Kinesis or Kafka as in real-time processing. It is used to send data from one API to another, or let's say you want to communicate some data across multiple programs, you can do that using SQS. And there can be scenarios wherein you would like to process data which is available in SQS, and SQS is part of your data engineering pipeline. If that is the case, you can use a Lambda to process data which is available in SQS.